Hello Year 12, welcome to our second video here for our 7th topic, Scale, Maps and Plans. Now we're going to expand on what we did in the last unit, the last exercise there, and talk about scale in a bit more of a specific sense, and I'm going to rely on this language even more, object size and image size. Remember, the object is the original thing, the actual thing, and the image is the map or the plan or the photo perhaps. Okay, that's how we're going to do this. So there are three sort of rules that are all just different ways of expressing the same thing. So my scale is my object divided by the image. Right? That'll give me a scale of 1 to something. Right? That's the simplest way to express this, object divided by image. That means that object equals image times scale, and image is object divided by scale. Those three rules, that relationship is important to remember. Let's scroll down and see how we can apply this. There is a reminder there, you have to use consistent units. Now, here we have a photo, and you might recognize this photo. This is a satellite image, a remotely sensed image of Maitland Park here. I've got a Maitland Park swimming pool here, and this is the basketball stadium across the road from school. Okay, so swimming pools, Olympic-sized swimming pools are really good for calculating scale on images because it's quite easy to see the edges of them. They're well defined. They're relatively easy to measure, and that allows us, and we know that they're 50 metres long. Okay, so that gives us a reference point on our image, and from that we can work out the scale, and from that, once we know the scale, we can work out other things, right? The size of other objects in our image. So, what are we asked to do here? Question 1, calculate the scale of the image using the swimming pool in the lower left for reference. So I would need to pull out my ruler here and measure that. I don't have a ruler. I don't have a ruler that I can use here, but I'm going to go that was 35 millimeters, was it? I'm going to say it was anyway. So here we go. I've measured my swimming pool. It was 35 millimeters. Okay, so in we come here, and I'll say that my object, stop that, that my object equals 50 meters, 50 meters equals 50,000 millimeters. Right, 50,000 millimeters. It's important that we use consistent units. Now we'll come back here and I'll say that my image is equal to, what did I say, 35 millimeters. Right, therefore my scale equals 50,000 divided by 35. This is not going to be terribly neat and tidy. I'm going to pull out my calculator here and work that out. Okay, come on down here, calculator. Can we see all of that? Pretty close. So I'm going to say 50,000 divided by 35 equals. So my scale is about 1,430. Okay, let's work with that. It's going to be approximate. Remember that I've measured that 35 millimeters. What was 35 and a half? What is 34 and a half? Really, two significant figures is being fairly generous with that accuracy. So a scale of 1 to 1,430 is probably more accurate than I really should be. But anyway, so let's come over here again. So my scale is 1. Why am I not on draw? Back over here. 1, 2. Sorry, technical difficulties. 1. Kidding me now? What? 1 to 1,430. Now the width of the swimming pool. I need to come back to this, pull out my ruler again and measure the width of that. I'm going to say when I measured that, I got a width of, let's say 15 millimeters, right? Let's say that's what I measured it at. You can measure it yourself and you might get something different. You get a different answer as long as you use the same process. So once again, I know my image. My image equals 15 millimeters. My scale equals 1 to 1,430. Therefore, my object is equal to, my object is equal to 15 times 1,430. Just realised back over here I wrote meters when it should be millimeters. Okay, there we go. And back to the calculator. Hope this doesn't play up again. All clear. Let's just 1430. I know what you're thinking. Why didn't I use the number on the screen then? Probably could have. Times 15 equals now 21,450. Oops. Okay, back here. Back here. Come on, Peter. Okay. Equals 21,450. Remember, that's in millimeters. And that's equal to 21.45 meters. Now, whenever you measure these things, whenever you calculate them, your measurement might be ever so slightly different, and that will have quite a significant effect on your final answer. Don't worry if your measurement was different, your answer was different, as long as it was in the same ballpark, I suppose, which means you're doing the right thing. Okay, to get the object, we'll do the image times the scale. To get the image, we'll do the object divided by the scale. Now, calculate the area of the basketball stadium. What I need to do is to measure both the length and the width. So I'm going to pull out my magic ruler and say that I measured that as being 32 by 75. 32 by 75. So let's write those things down. Now I've got 32 millimeters, 75 millimeters. They're my images. So I'm going to go to 32 times my scale, 1430. Okay, and back to the calculator here. Oh, that's not what I meant to do at all. Hang on. The pain of seeing me fumbling around with my graphics tablet and calculator here, I've done those calculations, multiplied my image by the scale to get an object in millimeters, and then I converted them to meters by dividing by 1,000. Now I have the dimensions of the basketball stadium, the object dimensions, 45.8 by 107.3. Now, of course, the area of a rectangle, and that's what it appears to be. Oops, it's not working. Oh, boo, here it goes again. Okay. Right, so area equals 45.8 times 107.3, and that's equal to 40, approximately equal to, oh, I've lost my pen again, 4,900 square meters. Square meters. And I'm going to say two significant figures there. Rightio. So that is applying scale to images and objects to calculate lengths and even areas. Okay, that's the second video done. Hope you enjoy. Thank you for being patient with technology. Okay, see you in class.